All right, students, continuing. Now, let's see how to convert to fractions. It's 4 steps, but I don't want you to cram it, okay? Let me say it. You can read it. If you want to read it, you can pause and read, but I'm just going to continue. Let me just take a sip of water. I don't want you to cram it. You can cram it if you want, but I'm going to give you the best way. Let me tell you this way. So here's what you do when you want to convert to fractions. The first step will never change. What will change is the second step. So the first step will never change. Here's what you do in the first step. Let me show you what you do in the first step. What you do in the first step is that you let x be the question you have been given, or the recurring decimal you have been given. Make it x. So you get different ones. You get different ones. Introduce x for whatever you get. Don't let me down. Step 1 never changes. What will change is the second step. That's the one that will change. The one where you will multiply by the correct power of 10. So what you're going to do, you have to choose a second x. You have the first x. Now you need to choose a second version of x. So you will subtract them and whatever. Here's how you choose them. You look at the digits that are recurring. You need to create a new version of x as well. Now, the new version of x you create, look at the digits that are recurring. If there is one digit recurring, then the next version of x I want to see is 10x. Okay, that's why we say multiply by 10. I want to see 10x. If you have 2 digits recurring, then the next version of x I want to see is 100x. If you have 3 digits recurring, then the next version I want to see is 1000x. Okay, 3 zeros, right? If you have 4 digits recurring, the next version I want to see of x is 10,000x. Do you hear me? That's what you want to do. So the next version of x you choose will depend on how many digits are recurring. So now let's do examples. I'm gonna do examples really fast. This is so easy. I know you can do it. So they're saying convert 0.5 recurring into a fraction. So you have 0.5 recurring. You want to convert it. You say let x be equal to 0.5 recurring. This is the first step. It will never change. So if I don't see it, then there is a problem. Now we need to create the second x. For us to create the second x, we look at how many digits are recurring. Here we have how many digits recurring? Only 1. So the next one we will say 10x now. That's the new one. 10x will be what? If you want to know what 10x will be, somewhere with a pencil you must write what 0.5 recurring means. 0.5 recurring actually means 0.555 ... So anyway, let me say this. If you have put a 10x, you move the comma 1 step. Okay, so you move a comma. So since these are 5s that are recurring, when you move it 1 step, one of 5s will come in front. Then you still remain with 5s only. So it'll be 5.5 recurring like this. Okay, it's like you move the comma 1 step like this. You now have 5.555. So it's 5.5 recurring. That's the 10x. So well done. You have introduced a new version of x, which is correct, which is good. You looked at the number of digits that were recurring and you did it correctly. So now you have x, you have 10x. What will you now do? You subtract them. You subtract them. So you say 10x minus x. You subtract the left-hand side, these two. These two, the 10x and the x. It is going to be equal to, you subtract the right-hand side now. 5.5 recurring minus 0.5 recurring. That's good. So this is actually 10x, by the way. It's 10x, not just 10. 10x minus x is 5.5 recurring minus 0.5 recurring. Now the recurrings will cancel. You remain with 5 minus 0. 10, here you say 10 minus 1. It would be 9. 9 of what? Of x is equal to... Now the recurrings have cancelled. That's why we do this. The recurrings will cancel. Beautiful. You now have 5 minus 0 is just 5. Which means x will be, you take 9 to the other side. 5 over 9. 9 goes to the other side to divide. And you'll be done. This is what you do. So this is it for the first solution. I'm going to stop the video here for the sake of the time. Then I'm going to continue with the other two examples in the next one. Now that we know the method, we're just following it. It's good.